Overhead camshaft. The overhead camshaft, OHC, design places the camshaft on top of the cylinder head, directly above the valves. The camshaft operates a set of lifters that directly contact the valves, and does away with the pushrods and rocker arms. It provides better breathing because the valves can be placed into the cylinder at a more flexible angle. Some engines use two separate camshafts above the pistons in a double overhead camshaft, DOHC, design. Engine cycles. Cycling is the number of strokes that a piston makes to generate power. Most vehicles on the road today use 4-stroke cycle engines. However, jet skis, snowmobiles, and many other vehicles that have a small engine, such as those used in motorcycles and chainsaws, develop power in 2 strokes. In the following sections, we discuss 2- and 4-stroke engines. 2-stroke engines. 2-stroke engines produce power in 2 complete cycles by firing once every revolution. 4-stroke engines fire once every other revolution, to provide more power for the amount of work expended. The advantage of the 2-stroke engine is that it does not have valves, and is therefore smaller and lighter. In a 2-stroke engine, both fuel intake and compression occur on the upward, compression. Piston stroke. The upward stroke of the piston creates a vacuum in the crankcase that pulls the air-fuel mixture in from the carburetor through an inlet port. At the same time, the piston seals off the exhaust port and compresses the fuel charge in the combustion chamber. Near the top of the upward stroke, the spark fires the fuel charge. On the downward stroke, both combustion and exhaust occur as the piston seals off the inlet port and begins to develop pressure in the crankcase. As the piston continues downward, the exhaust port opens and releases the burned gases. Near the bottom of the downward stroke, the inlet port starts to open to receive a fresh charge of fuel. The top of the piston in most small engines is shaped so that the air-fuel mixture swirls as it enters the combustion chamber. This clears the combustion chamber of almost all burned gases, and keeps the fresh air-fuel mixture from escaping through the exhaust port. 4-stroke engines. Most automotive piston engines develop power in a series of 4 strokes. A stroke occurs when a single piston moves from the top of the cylinder, called top dead center, TDC, to the bottom of the cylinder, called bottom dead center, BDC. When the piston moves from BDC back to TDC, another stroke has occurred. A series of 4 strokes is a complete cycle. The 4-stroke engine develops power in this sequence of strokes: intake, compression, power, and exhaust. Intake stroke. At the beginning of the intake stroke, the piston is at TDC. The top of the cylinder has 2 holes, the intake port to let in air and fuel, and the exhaust port for exhaust gases to leave after combustion. The intake stroke begins with both ports closed. As the piston moves down during the intake stroke, the intake port opens and the vacuum inside the cylinder draws air and fuel into the cylinder. When the piston is at BDC, the crankshaft has turned 180 degrees, the combustion chamber is filled with the air-fuel mixture, and the intake port closes. Compression stroke. During the compression stroke, the piston travels from BDC back to TDC, compressing the air-fuel mixture in the combustion chamber. During compression, the fuel particles are pressurized, thus increasing heat within the fuel molecules. At the end of the compression stroke, the crankshaft has turned another 180 degrees to complete 1 revolution. During the compression stroke, the intake and exhaust ports remain closed. Power stroke. As the piston reaches TDC again, the air-fuel mixture ignites. The rapid expansion of gases inside the cylinder forces the piston downward to BDC, to complete the power stroke. At this time, the crankshaft has turned another 180 degrees, completing 1.5 revolutions. During the power stroke, the intake and exhaust ports remain closed. Exhaust stroke. As the piston travels back up to TDC for the exhaust stroke, the exhaust port opens to release exhaust gases from the cylinder. When the piston reaches the top of this stroke, the exhaust port closes. The crankshaft has turned another 180 degrees. to complete 2 entire revolutions. Exam alert. Be sure that you understand the strokes of both 2-cycle and 4-cycle engines. 2-cycle engines have an intake compression stroke and a combustion exhaust stroke. 4-cycle engines have separate intake, compression, combustion, and exhaust strokes. Power overlap. Automotive engines usually have 4, 6, or 8 cylinders. In a 4-cylinder engine, no 2 cylinders are performing the same stroke at the same time, and one piston is always providing a power stroke to turn the crankshaft. The more cylinders an engine has, the smoother the engine runs, because additional cylinders mean additional power strokes to the crankshaft, so more than 4 cylinders provides an overlap of power strokes. Engine types. In the automotive world, you will see 2 main types of engines, the rotary engine, currently exclusive to Mazda, and the piston engine, both diesel and gasoline-powered. The engine is the automobile's source of power, and is a compound machine consisting of hundreds of moving parts. The engine converts heat energy from a combusted fuel to a usable form of power. To create this power, the engine mixes a fuel, such as gasoline or diesel, with air and ignites it to produce the heat. The type of vehicle that an engine powers, whether automobile, boat, truck, aircraft, or motorcycle, determines the power and size of that engine. Rotary engine. The rotary engine, shown in Figure 9.2, is a type of internal combustion engine that you will currently see only in Mazda vehicles and in aircraft. The rotary engine performs the same job as a 4-stroke piston engine, but with a rotary, instead of reciprocating, up and down, motion. The rotary engine doesn't use pistons, uses a rotor attached to an eccentric cam on an output shaft. Although they have a different design, rotary engines require the same support system's fuel, ignition, lubrication, and cooling that piston engines require. Seal. The rotor is inside an oval firing chamber, and has seals on each of its 3 points, so that it can rotate in the chamber, and create distinct chambers within the rotary path. Both ends of the firing chamber are closed and sealed. The chamber contains 2 side ports, one port connects to the fuel system, and allows air and fuel to enter the engine, and the other connects to the exhaust system. The spark plug screws directly into the chamber. As one face of the rotor sweeps in a clockwise motion past the intake port, a partial vacuum occurs in the firing chamber, then the seal crosses the intake port to seal off the chamber. The rotor continues to turn, it compresses the air-fuel mixture, and the spark occurs at a maximum compression. Rapidly expanding gases push against the rotor face and force the rotor to continue to turn in a clockwise direction. Power applied to the face of the rotor transmits over the eccentric shaft to the output shaft. As the apex of the rotor passes the exhaust port, the exhaust gases escape from the chamber.